Hmm. Yeah, so let's find
This is our initial computation,
hmm.
the one I shared a while
Sure, sure,
ago.
sure.
Hold on.
So can I can I see? Okay. So in
So
this,
we got the VCR.
okay, so let us see like this. Okay. So you have 400,000 ADT. Okay.
Yes.
Then 40,000 vehicle per hour. This is for the one link, one direction or two direction.
One Directions.
One direction is 400,000.
No, for both this 40,000 for One Direction.
40,000 is peak hour only, right? Per hour. Is that per direction or
Per vehicle per hour, per direction, sir.
I think the one that per direction is in here, the second, the next row, isn't it?
Okay.
Is that correct?
Yes, sir.
Okay, so because you assume, uh,
But this figure is from here also, sir.
I know. So you divide, for example, like 50-50, you divide by two, right?
Yes, sir.
So because you split 60-40, so you get the 60%, right?
Yes,
So
sir.
it is
That's the
24,000. Yeah,
24,000.
okay, so that's fine. So then assuming 2,000 per 2,000 PCU, okay, 2,000 PCU per uh, capacity, yeah, PCU per hour, right? That means 24,000 divided by, this is supposed to be 12 lane, right? Or 13 lane.
Uh, just 8, sir. That's the maximum number of lanes per direction.
So, okay, so if you divide this one, 24,000 divided 119. So how many lanes do you get? Supposed to be like 13 lane or 14 lane, right? I don't know how do you get 8 lanes here. Divide this one, 24,008 for something divided by this one,
That's 12, sir.
12
12.8.
more. You go here, equal, you just equal this one divided by that. Ah, you did not put numbers. You put it in string. 19. Ah, see? 13.
Yes, sir.
Okay.
But this is the actual, the 8 lanes.
So that means the actual one, this is not, it's already assumed that certain number of vehicles are using bus.
Yes, sir.
So this one we assume all 100% using car. If you
Yes,
use
sir.
car, all, you supposed to have 13, right?
Yes, sir.
So now one bus, how many passenger?
Mm. These
Okay,
were the data. 345 seats per bus. Depends on the bus capacity.
okay. Let's assume one of them. Which one do you want to use? Like let's make it 50. Is that okay?
Yes, sir.
So that's
The
easy to compute. Yeah.
Okay.
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 Okay. So say one bus is 50 passenger. Okay. So now if I assume all of these people using car, okay, car occupancy, you assume 1.5, right?
Yes, sir.
Example, uh, people per 1.5 people per vehicle. Is that correct?
Here's our EADT scaling.
This is the PCU value. I understand this one, but this is not representing the number of people yet.
Per people.
The one that you want to transport are people, not the vehicles. Isn't that correct or not?
Yes, sir.
Right. So now, assuming 13 lanes, this one, yeah, based on your numbers here, and this is so uh so 13 multiplied by or this one multiplied by 1.5, 24. Okay, yeah, by multiply. Okay, so this is the number of people per direction per hour. Bucks, bucks, bucks per hour per direction. Okay, so you get that value. Now you want to distribute, for example, if 100% of this using car, you need 13 lanes, right? So now you make a simulation, okay? So for example, 10% of these people using bus, 20% of these people using bus, up to 100% using bus.
So we divide this total number of people.
Say all of these people using bus,
Yes, sir.
assuming like 50, right?
Yes, sir.
Okay, so this one you divide by 50, how many buses? Below here. 50 divided by 50.
50 per bus. So
So
7.
you need like 737, 34 bus if all of them are using bus.
Okay.
This is 100%. So now one bus is like 3, your PCU value a while ago.
You see, 1 point.
Is that
That's
this
two,
one?
sir.
Where is your bus?
Here.
Oh, wait. No, a while ago, correct that one. But you did not have a PCU value for the bus. This is truck,
No bus, sir.
no bus in here.
Sorry, that's PUB.
The PC equivalent for bus.
That's two, sir. Two,
I,
sir, for
I think it's
bus.
about 3 lang. Bus and truck is almost, wow, your PCU value is very small, 2 only. And this is not correct also. Motorcycle is 3, wrong. Must be 0.25. How did you get this value? Is there any reference to this?
Then,
Yeah, I believe this is not correct.
Hi, sir. Sorry, I don't know if you can hear me, but we got that value from uh an article about. I think it's from no, no, no.
I think I
It's from
think
MMDA, but I think it was outdated. So
uh I think one of your uh,
but we had a reference for
The bus? I
The
think
one that we use for bus is the PUV, PUJ, PUV.
PUJ is like jeepney, right?
Yes, sir.
Jeepney is about probably 2, but bus is about 3, and then the motorcycle is 0.25
I
or
think
0.
it's wrong also.
Yeah, 0.3.
It's bigger than tricycle.
It's impossible if motorcycle bigger than bus.
Yes, sir.
So I think your computation, this one is incorrect. Can you search in Google PCU equivalence? I think one of the SURP students earlier already have this paper equivalence in the Philippines. Ada, no? Huh? There's tricycle only. I think one of the, this is tricycle only. Can you check maybe there are some papers already there? Oh, this is also NCTF. Okay, check this one.
This one, sir.
Mm-mm. No, this is India. But it's okay. I think the value will not change so much. Or you can use Wikipedia there. Yeah. For the bus. How much is the bus? No. Bus is
Bus for
2.
coach 2.
Okay. So motorcycle 0.4 in London.
Yes, sir.
Yeah. Okay, so let's make it 2 or 3. Okay.
Or 3. Higher value since it's bus. Bigger than jeep.
Okay, so let's say bus is equal to truck. So let's come back to your computation a while ago. Now, this one, right? So this one, 700 multiplied by 3. That one is PCU value per hour per directions. So that one is practically, if you have 100% bus, you only need 2 lanes because 1 lane is 19.
Yes, sir.
This is not vehicles, this is PCU. Yeah.
That's for 100%, sir, but we
Yeah.
still need to
Okay,
add.
so now let's say you have only 10% of that. So you can put 10%, 20%, 30%, 40%, and so on.
So that's for our scenario 1, sir.
Oh,
We identify uh the capacity
so how many lanes do you need, and then how many bus do
per
you?
percentage and how many bus.
Right?
Okay, sir.
It's not supposed to be difficult, right?
Yes.
So you can try here, say 10%, say try. 0.1. Oh, there, only 220. So, but be careful. This is only the bus is 220. Okay, so multiply exactly the same, you copy. So you put 10% here. Okay, that's exact copy.
50. That's 50, sir. Of
Yeah.
you. 50 also.
Yeah. Say you can change if you don't like 50, you can change it 45. That's fine also. Based on your value. Oh, okay.
Divide. So 73 users.
Only bus. This is the number of bus.
A bus.
Okay. And then this bus multiplied by 3. Okay. Wait, this is only the bus, but you did not get the PCU value yet. So if 10%, so how about 90%?
Okay, sir.
So then at here, at the bottom here, you calculate. So for the car now, so you have 90%, right? So 100 minus 10% here.
Oh, yes. 90 for the car.
Correct. So
0.9.
just 1 minus that one so that you can get the formula.
1 minus.
Minus this one. Enter. So that one, now you multiply 90% multiplied by this one. Okay.
So this one's for the.
Right. And then now you multiply by 1.5, right? Oh, sorry, divide by 1.5. Divide by.
Or 50.
Oh yeah, correct. Divide. And then you multiply by 1 because car is 1, right? No, that is this correct, 1.5. This is
Yeah.
correct. So, and then you divide by 1. Multiply by 1. With this, no, that one multiplied by 1. Because passenger car is 1. Correct?
This one.
Yeah. No, this the 22,000. Okay, so now you add this 22,000 with this 20,000. So total here. No, only this one plus this one. So you will get 220. Okay, so now divide this with your 1950.
19 only.
19, okay. That is, so you put for sailing so that you can get the number of lanes here. Sailing of 11 something of this one. Those. Oh, okay, so you need 12 lanes. Okay,
For
now,
10%.
yes. Now you just change the percentage and copy all here. Okay, now you put 20% here. So that one is 20% multiplied by this one, right? So here you multiply. If you already use formula and then multiply by this one. Actually, if you already use formula, you just copy once. Do you want to use formula? Okay, let's use formula. Go here, I will see your formula. Okay, so this one is remove this 0.1 and then put it in here. What is that? 8, 7,
Yes, sir.
F or 8? 8, 7. No, this is not correct. F7 multiplied by 8, 6. Okay.
Here, sir.
Yeah. You need to put dollar.
F7. Mm.
Yeah, F7 multiply by 86. 86. 8. Okay, enter first. And then F7 is supposed to be double dollar. So, because you don't change that. And then here you put dollar in the 6. Okay, enter. Okay, how about this one? You put 50 in here so that we can use that as numbers. You can change later if you don't like 50. No passenger per bus, this one. Okay, so then this one you can modify, divided by this one, dollar dollar. F4. Okay, only F4 you put double dollar. No, that one no dollar. Only the F4 you put dollar dollar. Okay, this one also you set here 3. Later if you don't like 3, you can change that. So this one is PCEF, right? Okay, then multiply by dollar dollar of that one. Okay, so this one is already formula. This one you need to change the formula so that put dollar. The H13 is dollar. Double dollar. Okay. That's all. And then 7. Oh, what is this? 13. 13 is dollar without the H. The H you don't put dollar. Only the 13 you put dollar. Okay. That one you put dollar dollar. F7 you put dollar dollar. Because do you understand how to put dollar sign? The one that you don't change, you put double dollar. The one that you change, you don't need to put any dollar sign. Okay. This one now you put here 1.5 passenger per car. Okay, same. That one you put dollar dollar in the F. No, it's no need to put dollar because you will copy later.
Oh.
Okay. That one you change. Enter. And this one's supposed to be okay. You want to put 1? Of course, no need, yeah, because car is always 1. Okay, that's one is fine. So now you can copy the entire of this here. Yeah, oh, and then now you increase 30, 40, 50. Just add. Oh, and then you just copy entire this one. You copy all of this because you already put in the formula. See, point out. Yes. So now you have the number of bus. Okay, this one, right? This row is the number of bus. So you can change now the 50 or 1 to how much is your actual value? 49, 45. Okay.
Okay.
Yeah, so okay. So if you don't want 3, you can put 2.
Okay. But we'll research for
Yeah,
the
okay.
value of
Anyway,
bus.
so these are the one that you input from the literature. So you just put any yellow color there so that you know, right?
Yes.
Okay.
For scenario 2.
Hmm. So at least you know uh, how many bus do you need, right?
Assume one lane.
Yeah, assuming. So these are the number of buses to accommodate. This is sensitivity analysis, isn't it? You can plot if you want.
Yes, sir.
Okay.
So we'll just proceed with the scenario and then
So these are the traffic volume, isn't it?
yes.
How much? This one, is that correct? This one, this is your traffic volume here,
That one, sir, we assume only.
right?
Uh
This one is this one. This one you multiply by the number of lanes. Your current lane is 8.
yes, sir.
Okay. So this one we want to find the number of lanes. So if you divide by 8, then you will know what is the congestion level. Assuming you don't change the number of lanes, that means so 8 lanes that means they assume already 50%, isn't it? Is that correct? 50%?
For the
For the 8 lanes here.
yes, sir.
So that means about 50% of these people are already using say if this is 1, if the VCR is actually 1, this is exactly about 50% of these people are using password. So is that correct or not?
Yes, sir. The
The
for
current
this
condition, the current condition here.
yes, sir.
So then you said you want to improve. That means how do you improve? So you can increase 60%, 70%, and so on.
We double we double the we multiply the current number of bus.
You increase the number of bus. How many bus that you have right now?
Um
Actual condition. How many bus that do you have right now? This is the only bus that you have.
yes, sir.
That's impossible.
For that route, sir, because we're just analyzing route 2,
This is only
11,
only
12,
like
15 buses.
15 buses, but you need how much oil ako? 400 lah. You in 50% only you need at least like almost 500 buses.
Sir, sorry, I have a question. I don't know if you can hear me. Um, sorry. I don't know if you can hear me.
Yeah, okay, I can hear you.
Ah, that's better. I have a question, sir. I actually chatted it because we're also assuming that the passengers that we calculated will only use 50% of the volume. This computation that you showed us earlier, it
Okay.
assumes that everyone will use the libreng sakay. But
Correct.
what we wanted is to what we wanted is to only transition some of them, 50% of them to the libreng sakay and 50% to use the public buses. How
Hmm.
do we compute that?
So this is like all of them. Now you split the bus, right? So this is all the public buses, and then now you have additional what do you see? Yeah. 50% using
50% using the bus.
50% using this free bus.
All buses.
Actually, you need to model what is called model split model. Mode choice. Do you remember I gave mode choice in the lecture?
So we need to segregate each number per. So sir, here's the uh this is from the data that we gathered for the Commonwealth where the route traverses.
Where? Which one is the? This is only the traffic flow. This is not about mode choice. Okay, I will share screen for a while. Is it okay?
Yes, sir.
I hope you remember this model. Do you remember? In the slide of mode choice. And we're supposed to have a model something like this. This one. The value of this 0.3, 0.18, and 1.95 is, of course, depends on your city. Okay, so if not, you can just search in the literature what is their model. But more or less, the value is similar like this. So now if you put initially how much, and then if you change become 0, how many people will increase to use pass? Then you will know the increase of demand. So you can know.
Oh, people who will use the bus.
Yes. So you need to have this kind of model. I hope you remember this one we discussed in the class. So if your bus fare become like this, yeah, if you have certain congestion pricing or the travel time actually improve and so on. So then you can, how many percent of this will shift, right? So this one will go back to your model. So because you know the percentage of shift, so you will know how many people will use this. This is the demand model that you need to use.
What if sir, our study doesn't cover the bus fare.
No
We have no
problem.
data.
This is the
Then
difference.
assume,
This is the difference. So assume the current condition, and then remember delta here represents the difference. What is the current condition? The bus fare. And then now you change it into zero, isn't it? So the difference, how much? It's a comparison. This one is a comparison. So assuming that the only option is 50%, what do you mean by that? So of course, not everyone will use this bus and car. Okay, so you can assume something else then. Okay. So some of these will use the normal vehicles, and some will use this Libre Sakai, isn't it? Are you still there?
Hi, sir. Sorry. Was the question directed to me? Sorry, sir. I'm currently outside. That's why
It's okay.
I was the question directed to me, sir?
What is the question?
Um, my question on the chat box was if the computation that you showed us earlier only assumes that buses and cars are used. But what we wanted is to set percentages for those who use within Sakai. Those who will still use the public buses, the public transportation options, and then the cars. So how do we do that?
So you split again the one that you use bus into two, right? Okay. So
Oh,
one is the one that normal bus that is not delivering Sakai. The other one, or the normal jeepney or LRT, and then the other one is the one that delivering Sakai. So so in that case,
sorry.
depends on you. So uh, how many buses delivering Sakai is providing?
Currently, there are only 15 buses that run along the route.
Okay, so uh, if you want to get 15 buses, the 15 times 50 people, okay, per trip, yeah. So I assuming the load factor is not included. So that means 15 times 50, how much?
50, 760.
750. And a while ago, can you show again, please, the table that you compute a while ago? Okay, so assuming, yes. Now, how much is the 15 buses multiplied by 50?
That's 750.
750 passenger. 15.
Yes, sir.
Okay, so that will be deducted from this value, isn't it? Will be deducted from this passenger value. Is that correct?
Oh, so the division of the percentages will only affect the number of uh passengers on the bus and not the whole um number.
No, because this is the whole number, right? So you give free service, and then we assume like 100% of them will be use this. But the problem is actually you are limiting the number of buses. Is that correct? You are only having 15 instead of 160, for example. You are only giving like 15. So in that case, you can only accommodate 750 out of how much? Now is 50%. So out of 18,000 passengers, you are actually contributing very small.
Sir, this number of buses that are being computed here, we just wanted to get the 50% of that, and that's what we want to supplement to the living
50% of
sakay
that means you just divide this one, divided by,
by two.
yes. That means you need
Okay.
200, not 15.
Not just 15 buses. We still wanted to increase the number of buses, but we wanted to stop at least 50% of the passengers that are computed.
So this is the number of passengers that you have, right? And
Yes,
currently
sir.
you have 8 lanes, so I'm guessing you are in here because of this number, right? Your current lane is about 8 lanes, right?
Yes, sir. That's correct.
So in that case, you are about at this point about 50% already,
So
right?
if my analysis is right, if we wanted to maximize the 8 lanes, sir, we need to at least have 408 buses for
Correct,
the libreng sakay. Is that right?
correct.
Yeah. Okay,
If
sir.
you are telling only
Now,
50%,
clear.
that is at least 200 of them. At current condition, yeah. This is at current condition. This is your, I assume the current condition because of the 8 lanes, right?
Sir, how do we assume the number of lanes if we wanted to have one or two dedicated bus lanes?
So,
Do we increase the number of lanes or decrease?
so if you want to, again, if you want to do like that, you need the mode choice model. Because in the mode choice model, you have the travel cost and travel time as an input. In this model, you don't have that. You got it? In this model, you're only having the flow. You don't have the travel cost and travel time. That's why I'm suggesting find existing. You don't need to create your own model. There are a lot of studies in NCTS or in SURP, okay, about the bus and the car. Okay, so you just use their model. Okay, they have the coefficient. They already did the study. So all you need to do is just use their formula and then input your data there. Okay. So for example, you want to have dedicated 1 lane. That means the speed of the bus increase, isn't it? So what is the current condition? And then now you have the dedicated bus lane. So what is the travel time? Say from 20 kilometer per hour, now you can make it like 40, I don't know. So in that case, you double the speed, okay? Meaning the travel time you reduce so much. So in that case, how many people will shift to this bus? So you are playing with two factors, right? One is the travel cost, the other one is travel time. Okay? By you having a dedicated lane, that means you increase the travel time. Okay? By having it libre, so free, that means you are playing with the travel cost. So assuming all of these people will, the one who use bus already, so they will use, because they are already paying like 16 pesos, 20 pesos. How much?
That's 25 pesos.
Say 25 pesos, and then now you give it for free. Okay, this 18,000 people per hour per direction. So you give it for free. Will they use that free buses, or they will still use the one that not free?
I think that would encourage them to use the free.
Exactly. So in that case, that's why I'm saying you will assume 100% shift from the existing bus, huh? So that's why we use like 750. This is assume 100%, isn't it? So I don't know if this is good policy or not, because you are competing bus with bus. So in my opinion, this is not really good policy because you are competing bus with other bus. You're supposed to compete the bus with car, right? So how to do that? You remove all the non-free. You make it all free. Then they will go from car. Okay, they will go to this bus, isn't it? So, and then the one that not free, you increase the comfortability. That is for the middle class. Okay, say 25 pesos, they get free Wi-Fi. See, and then
So
not
for this study particularly,
sorry, what?
For this study particularly, we'll just stick with the 100%. I mean, with
Yeah, because it's
100%
libre,
going
so
from
it's
cars
must be
to buses.
100% going there,
Okay.
right?
We'll just not complicate the percentages.
Yes. So, but for the purpose of policy analysis, this is bad policy. Okay, not good policy at all. You're competing bus with bus. You're not competing bus with car. Anyway, maybe this is the first step. That's fine, no problem. So once you reach certain number of buses for the mass, no, for the masses, then you start to introduce for the middle class. Okay. The purpose of mode choice is not target
Yes,
the
sir.
poor. This is always wrong. The transportation people are not doing the right policy. You are not making this right. because you are putting the competing between the bus, existing bus which is paid with the free one. So that means the poor people will use the Libre, the free one. Okay. My question, your number of free is so small, it doesn't have any impact at all. People will not use car, the car user will not use bus. So this is hardly good policy at all. Do you get the idea?
Yes, I do understand. Yes, sir. I do understand what you're trying to say. But I don't know if this stands true, but in the Philippines, unfortunately, the government is not allowed to um monopolize the public transport, if
Don't
that's
understand
the
that.
right term.
I don't understand that. I don't understand why government is not allowed to monopolize the public transport, which is already free. I don't understand the policy at all. So you cannot monopolize the one that is not free. Okay, which is for the middle class. That's correct. But for the one that is free, must be 100% government.
Yes, sir. I I do get that. I think that's where the policy fails because they only provided like a limited number of units for the people. That's what the study is actually about. So how we wanted to identify the optimal number of buses will serve the number of
Minimum
seats
400
for
at current
yes, sir.
condition. Right. So 15 is very touch at all. That's the point. So if you are honest with your study, you need to tell that the truth so that the government will start to realize something.
Yes, sir. We'll actually include that. Thank you so much for that suggestion. We'll include that in our recommendation.
Right. So it's okay. As a scientist, you need to tell the truth, so that the government will understand that also. I understand they want to do it for political reason, okay, but probably for popularity and so on. Okay. But for the policy analysis, this is no good. So that should be the conclusion of the study,
Advice.
Hmm.
Or
Is that
how
okay?
do we calculate the
How do we calculate that?
sir, the one you were saying a while ago? Because we were comparing bus versus bus.
Look at it this way, okay? Your need, a while ago, your table. Can you show again the table so that we can see? Okay, so your table, you are telling car lane is 8 lanes, right? So I'm looking at your table, which one is 8 lane? Here, I have 50%, which is 8 lane. Is
Yes,
that
sir.
correct or not? Okay, so assuming this is correct and this is not really congested, or congested, but at exactly the same capacity, that means you have 50%. 50% of the people are already using bus. That means you are having already about 18,000 people per hour, per direction, are already using bus. So I don't know if correct or not. So at this point, you
The
are
other
already,
half, the other half is using car.
the other half is using car. That's why you are exactly at capacity. Okay. So you need to know the actual VCR there so that you will know the actual value. Nah? If you know the VCR, the actual VCR, okay, then you can put it back to the table. Then you will get the actual value. For example, this one or this one, I don't know. Right? So you get the way to analyze. It's reverse. Okay, you need to know this one first, and then from there you will get from this table, you will get actual number of passenger per hour per direction, isn't it? So from the number of people, then you will know what is the number of bus that you need, right? So now let's assume this value so that easy to get, okay? So assuming that you are already at current demand, you need about 400 bus based on this value, okay? So that means at this current condition, you already have around 400 buses, which is probably not free. Is that correct or not?
With the 400 buses.
Yes, sir.
At current condition. Now, with this current condition, suppose you have 400 buses there running there, okay? And then you want to add 15, which is free, okay? So out of this 18,000 passenger, how many will use the free one? Of course, the number of buses free is 15 multiplied by 50, right? So you get 750. That means 750 people will use this out of the 18,000. Is that correct or not?
Yes.
So, but because this is so small compared to this one, right? So the quality of the bus service, the remaining, the one that actually not free, will not improve, right? So they will not improve. In fact, they will just reduce their demand. So in that case, okay, you are competing bus with bus, not with car. So the one that you need to introduce is three-way. Okay. Number one, you introduce this free bus. Number two, you introduce the middle class bus, similar to the one that from say Katipunan to BGC or Katipunan to Makati. That one is like 100 pesos, no? Okay, with the Wi-Fi, and then maybe have some coffee inside and tea. So this one is for the middle class. More expensive, okay. They are the one that will compete with the car user. So now the revenue from here will subsidize the free bus. The revenue from the middle class bus supposed to subsidize the free bus. Also, if you want to have tax, congestion tax here, is supposed to the revenue from the congestion tax supposed to put for the free bus. Then people will not use car. People will use this two type of buses. That's supposed to be the policy. Only one tier, only free bus will not improve. System thinking, no?
How do we know, sir, the number of middle class bus that we're gonna introduce?
Oh, that one is another study.
I think that's for us to set because what sir was trying to say is that just to cater to this number of passengers, this has to be the free buses has to be increased. Tama, diba? Sorry. Sorry, sir.
So
Yes, but
the current condition not enough, the bus, that's why you increase.
yes, because it's just 15 buses. So with the 48 that's required for the current condition, 408.
So 15
So,
compared to 408, that's too small, isn't it?
yes, sir.
Hmm.
So then we introduce the middle class bus, but so we just assume the number.
If you want to study the middle class bus, okay, so you do what is called mode choice study. That means your target is not the poor. Your target is the middle class. So you do questionnaire survey, you ask them, how much is your income? Okay, are you willing to do to pay this much for the bus? Okay, will you see from you having car and not? Then you ask if they are already using bus, not using, and they don't have car, they are not your respondent. Can you see that? If they don't have car, they are not your respondent. They are not your target market. So this is the study that you need to conduct if you want to do for the middle class bus.
Because we can't recommend a policy.
So that you can recommend the policy because you want to ask them, okay,
Sir, what's the minimum number if we're going to conduct this number of
the sample number. Sample
yes, sir.
number depends on the way you sample, no? So do you use random sampling, stratified samplings? That's different way to compute, no? So how much is the middle class user? You should know based on the range of income, you will know. Okay. So you need to know the range of income middle class user. I don't know, say from 40,000 to 200,000 or 100,000 per month income. I don't know. That's probably the range, or maybe from 30,000 pesos per month up to 100,000 per month. That's probably the middle class, right? So now,
Yes.
how many people are the middle class income there? And then you supposed to get like how many error that you want to allow. Okay, from the number of error that you allow, for example, like 5% or 1%, then you can get the Z value. Okay, you can search in Google, determine the sampling number. Okay, to get the sampling number, that means you need to know the actual population that you want to target. And then how much is the rate of error that you allow. From there, you will get the Z value, and then you can calculate the number of samples.
Yes, sir. But I think that's for another study.
Correct.
All right. Thank you. So we'll just focus with assuming that we wanted the policy to work. and that will assume 100% transition from cars to bus.
For
Sorry.
this study, I hope you will tell the truth, no? So, okay,
Yes, sir. We
this
will.
is what we calculate, okay, and this is what you have currently, and then this is what you suggest,
Yes, sir.
okay, and what is supposed to be the policy that you suggest.
Yes, sir.
That's what I hope to have. Okay?
Just
Even if you can calculate the say using the existing mode choice model from the literature, yeah, the previous study, that's even better.
Copy, sir.
Yeah,
We'll try to compute that one also.
right,
Just so we wanted to, just so we'll see the attraction percentage, if that's,
right.
yes.
Okay, so okay, so it's closing the
Thank you, sir.
no problem. It's closing the almost end of the year, so I hope you can finish by next week or
Yes, sir. We'll try to squeeze it in until the week. When will you be available to the final presentation?
anytime. I have no problem until the end of the year. I have no problem.
Thank you, sir.
Yes.
We'll just email you again. Thank you so much
Yes.
for your time. We're so
No
sorry
problem.
that we're not able to, but we learned so much actually
Okay, so I
with
hope
this one-on-one.
good enough for you. Check again the mode choice and the bus computation last time.
Yes, sir.
We discussed it in the class.
Yes.
Thank you.
thank you, sir.
Thank you, sir. Thank you for your time.
Bye bye.